5.2 part 1. Let's start off just reviewing our exponent rules. Okay, these are exponent rules, as I said, you've learned before. The difference is algebra 2 level, we're putting fractions in there. Okay, so you may or may not want to have a calculator with you. So basic review here, okay? Product of powers. So when you're multiplying two pieces and there's exponents involved. The idea is as long as the base is the same, what's the shortcut when you're multiplying and there's exponents? You keep the base and you add the exponents, right? On the flip side of that, what about a quotient? If you're dividing and the bases are the same, you keep the base and you subtract, right? Those should sound familiar, okay? A power of a power, that's just saying if you have a power raised to a power, you multiply. Power of a product, this goes along with it, that if you have a product raised to a power, that m goes on both pieces there. Okay, so if you have an exponent and there's a product inside, it goes on both pieces. Negative exponent. So we talked about this one yesterday. Okay, so this is more review here. Negative exponent. How do you get rid of a negative exponent? You take it across the fraction bar. And anything raised to 0 is always 1. And guys, if you have a calculator by your side and you don't remember, the cheating thing is put it in your calculator, right? I don't even know if I should call it cheating, but the check yourself is put something in the calculator, raise it to 0, and you're going to get 1. Okay? So, we're going to use these properties. And we're going to work through these problems. So, let's look at A. 81 to the 5/6 times 81 to the negative 1/3. Okay, the bases are the same. We're being told to multiply, so the shortcut is we're going to add the exponents, yes? So I'm going to rewrite this. Actually, I'm going to scoot this over a little bit. As 81 to the 5/6 plus negative 1/3. Okay? It looks fancy because it has a fraction, but it's the basic rules you've been doing since middle school. Keep the base the same and add the exponents because it's a multiplication problem. Now, what's the catch about the exponents here? There's a negative and yeah, they're fractions. They don't have a common denominator. Okay, so we're going to have to do some fraction work here. Yes?
So I'd say the answer to the equation is, question is 9. Wait a minute.
Give me some middle steps there.
Oh, wait, because it wants us to rewrite each expression using the properties. So this isn't one specific.
We are going to eventually get to a solving point. So like right now, what I've done is I've rewritten it.
81 to the 5/6 plus negative 1/3.
Yeah.
So that means 1/2.
Because how do I add 5/6 and 1/3?
How do I?
A common denominator of?
You add 5. Okay, say your question again.
How do I add 5/6 to negative 1/3?
5/6 to negative 1/3.
In other words, you went ahead and said it's 1/2. I'm not disagreeing. But
yeah, I know, but so negative 1/3 is 2/6.
Okay, are you guys with them?
Negative 2/6.
Right. Common denominator. 3 and 6 both go into 6. 3 times 6 is 2, or 3 times 2 is 6. So 1 times 2 is 1. Okay. 3 times 2 is 6. So 1 times 2 is 2. Are we there? And here's the deal. Ashley did it great. I'm trying to make sure, though, that everyone's caught up that we need that common denominator and how to get it, right? And then what is 5/6 plus negative 2/6?
Yeah, 3/6, which is a half.
Right. I'm going to say 3/6 to start with, but we all know 3/6 reduces to 1/2. Are you guys following? What do we know about 81 to the 1/2? Because here's the deal. Sometimes we'll stop here today. But if you can go farther nicely, We want to go farther. What does a 1/2 mean? What did we learn yesterday?
Square root.
It's a square root, yes. So that 1/2, 81 to the 1/2 is the square root of 81.
Which is 9.
We know the square root of 81 to be 9. Okay, are we all there? As I said, I wasn't disagreeing with Ashley, but I need to get some middle steps in there to make sure everyone's with me. Okay? That's using our rules we know. Notice the 81 we had to keep it the same. Okay. Let's try B then. 2a to the 1/3 times ab to the 1/2 raised to the 2/3. There's a couple things that have to be done. Guesses of where to start?
Is it like the power of power one?
It is the power of power 1. Technically, I would call it, instead of power of power, I would call it power of product. Because what does this 2/3 go with? It goes with the a, and it goes with the b to the 1/2. Okay, so I would start there by rewriting it. The 2a to the 1/3, I'm going to keep as is right now. And then this 2/3, it has to apply to the a and the b. When you apply it to the a, it's just going to become a to the 2/3. And it's going to become b to the what? What do we do with the 1/2 and the 2/3? This is where it goes back to power of power. When you're raising a power to a power, we're going to multiply. So side note here, what is 1/2 times 2/3?
Four over 3. Nope.
No.
Okay, cross it.
2/6 or 1/3.
You guys there? Yeah, just multiply straight across. You can say 2/6, which does reduce to 1/3. Or, I know many of you aren't like me, and that's fine, but I like to just reduce my 2's and go straight to the 1/3. Okay? So this is, can we agree this is b to the 1/3? Okay. So now I have 2 times a to the 1/3 times a to the 2/3 times b to the 1/3. What's another step we need to do? What needs to go together? The a's, yes? Okay. The 2 is just a whole number 2 that's going to be out front. The b is just b to the 1/3. It's the only b, so it's going to just stay as is. But we need to put the a's together. What do I do with the a's? I'm going to keep the 2. A is going to become, what do I do with those powers? Add, right? If you're multiplying and the bases are the same, we're going to add the powers. So we're going to add 1/3 plus 2/3. And you don't have to write this step if you just want to jump to the final answer. What is 1/3 plus 2/3?
1.
3/3, which is 1, yes? So what can I clean this up to be? 2, a to the first, which we all know I can just write a, b to the 1/3. Now, can we do anything with that? No. This 1/3 means what kind of root?
Cube.
Cube root, okay? Can I do the cube root of b? No. So in my notes, and I'm wishing I remembered, this one, I said don't leave it as 81 to the 1/2 because we can do the square root of 81. So definitely keep going. This one, I would say you could leave it, or you could say this is 2a times the cube root of b. I have both of these circled in my notes. Okay? I have both of those circled in my notes. So either or. I got in and was looking at lesson 1 to see what you guys had done in Savas and everything, but I forgot to check this assignment out and see how they were leaving things. So, okay. Are these exponent rules starting to come back together? They're a little bit there in your heads, I hope. Okay. Let's look at C. Now, okay, I learned from my issues in the last lesson. I tried to make the negatives more obvious. Do the negatives on the fractions look a little more obvious? Okay, so I tried to make the negatives obvious. Now, there's 2 different ways we can start this. Well, there's a couple different ways we can start this, but I definitely have one that I'm going to prefer. Do you guys have any thoughts?
Combining like terms.
Okay. Combining like terms, essentially, and what do we basically have? We have an x times a y times another x times another y, yes? So when she uses the phrase combine like terms, which technically we save that for adding, but I know what you mean. I'll go with it. We're going to put the x's with the x's, the y's with the y's, right? So now when we do this, so we have x to the 7/8 times x to the negative 4/3. What do we do when we combine those? We're multiplying them. They have like bases. What do we need to do? Because we're going to have to add those fractions, right? So I'm going to write it as this is going to be x to the 7/8 plus negative 4/3. I'm going to go ahead and write the y's, and then I'll do common denominator in my next step. And then we put the y's together. What's happening with y's?
You're the same.
It's y to the negative 3/5 plus 3/5. Well, that one looks better than the x's, doesn't it? Okay. In order to put the x's, I was told I need a common denominator. What would be a common denominator between 8 and 3?
None.
Oh, there's something.
24.
That's a big number.
24. But 3 and 8 don't multiply into anything the same before 24. So we are going to do a common denominator of 24. It's not that bad, I promise. How does 8 become 24? Times 3. So what do we do with 7? Times 3. Okay. And this one, there's going to be a negative. How does 3 become 24?
8.
Multiply by 8. So what do I do on top? 4 times 8, which is 32. Now, I don't want to lose track of my y. We already have a common denominator with y, don't we?
5.
What is negative 3/5 plus 3/5? 0.
I was going to say actual numbers.
Negative 3/5 plus 3/5. Opposite signs are canceling each other out. Okay, let's go back to x. 21/24 plus negative 32/24. Well, I know it's something over 24. What is 21 minus 32?
Negative.
That's what my brain has on it. Negative 11/24.
Yeah.
What is anything raised to the power of 0? 1. Nothing. Okay. I'm going to say 1 officially. But here's the deal. If it was the only piece of the problem, we'd say 1 and that would be our answer. Do we need to list it?
No.
I mean, it's going to be 1, so you can say times 1, but we can also just drop it off. Okay? Now, not quite done. Savas isn't going to be happy. Neither is any math teacher going to be happy. What are we not allowed to leave most of the time in math? A negative exponent. How do I deal with getting rid of a negative exponent?
Put it in under 1.
Move it to the denominator, right? We talked about that yesterday. It's up in your rules. Move it to the denominator. So when you move this to the denominator, it's going to become 1 over x to the 11/24.
Hold it right there.
Okay. I have this as my final answer. I personally did not go to a radical on this one because it'd be the 24th root of x to the 11th. Yuck, you know. Unless you have reason to go there, I probably would not say go there. Okay? Okay. Trying to give you a variety here of exponent rules. So let's look at D. A to the 3/2 times B to the negative 4/3 raised to the 4/5. What am I going to do first?
Multiply the 4/5 into the other things.
Okay. This 4/5, this power has to go to the A to the 3/2 and the B to the negative 4/3. Okay. So it's going to be A, power raised to a power. Remember, you're multiplying. What are we doing? 3/2 times 4/5. You can multiply straight across and tell me that it is
1/2. Wait, no, never mind.
12 over 10. But then you would have to reduce 12 over 10. 6/5. Or what I like to do is 2 and 4 cross cancel. 2 divided by 2 is 1. 4 divided by 2 is 2. And then 3 times 2 is 6/5. If you multiply and got 12/10, it reduces to 6/5, right? So this is going to be A to the 6/5. And then B. What are we doing on B? Negative 4/3 times 4/5. I don't have any cross canceling here. So I'm just going to multiply straight across. Negative 16/15. Okay. Next step. We're almost there, actually, but we can't leave it in this form.
The simplify.
Under 1? Well, okay, so here's the deal. Negative exponent, we can't leave it. It goes where? It goes to the denominator. Now, what about A to the 6/5? Can I leave that? Yeah. So if I'm leaving that, where is it staying? It's going to stay on top. So what's going to happen here is that I'm going to keep A to the 6/5 on top, And I'm going to move the b to the bottom and make it b to the 16/15 to get rid of the negative exponent. I can't go any farther because a and b are not the same base. So I'm going to stop there. Okay. Ready for E? And stop me if you have questions. As I said, I'm just trying to show different things. You're going to see a variety of things in homework. Okay. E, x, y to the third over x to the 1/2 raised to the 2/3. There's definitely two different directions we could go here. Kind of depends on what you see. I'm guessing I know what you're going to see first. Thoughts of where you want to start? What? Okay, deal with that outside power. Now, what's that 2/3 have to go on?
X and Y.
It has to go on x and y to the third on top, and it has to go with x to the 1/2 on bottom. Okay, so it goes with everything on top and everything on bottom because it's outside of that parentheses. Now, on top, that's going to be x to the what?
2/3.
X to the 2/3. Y to the what?
I don't know.
What do we do to get the power on Y? What do we do, Hayden?
3/1 times 2.
Yeah, you're going to take the 3 and the 2/3 and we're going to multiply. So to multiply 3 times 2/3, 3 as a fraction is indeed 3/1. So what about 3/1 times 2/3? I like it. I was going to say it, but I like it. Yep. The 3's cancel. What do we end up with? 2/1 or just a 2. Okay. Or you end up with 6/3, but 6 divided by 3 is 2. Okay. What about the bottom? X to the 1/2 raised to the 2/3. So we're going to do what? 1/2 times 2/3, just like what we did with the previous one. What is 1/2 times 2/3? 1/3. Okay. We're not done. Why aren't we done?
We have 2 X's.
We have 2 x's in the same problem, yes? Okay. If the x's were both on top, we'd multiply them, right? So we'd keep the base and we'd add the exponents. Since we have an x on top and an x on bottom, these x's are being divided. What's the rule for when we're dividing? Keep the base and do what with the exponents? Subtract. So we're going to do x to the 2/3 minus 1/3. And then we still have the y squared. I don't want to lose track of. What is 2/3 minus 1/3? 1/3. So we have x to the 1/3, y to the 2nd. Now am I done? Which is it?
Can't be.
Okay. And I would say, I agree, you can be. I would be fine with x to the 1/3, y to the 2nd, or x to the 1/3 is something that would be easy to write as the cube root of x. Now, if we do that, I would put the y squared first and say y squared times the cube root of x. In all honesty, I almost prefer the first one on this particular problem. Just, I don't know, it's just a little easier to write. However, if you had to go out of fraction exponents, you could do that. Okay? Hey guys, one more. The key is going to be able to do these on your own. That's going to be the catch. Okay? Okay. Thoughts on F?
Those are the last one.
Yeah, you do. So you just
Okay. The 1/2 goes with the 3, and the 1/2 goes with the 32 to the 2/5 on the bottom. Okay? So, on top, we're going to have 3 to the 1/2. Okay? On bottom, 32 to the what?
Oh, I mean,
Me too.
you would times the 2/5 and 1/2.
Okay, we're going to have to take the 2/5 times the 1/2. When we do 2/5 times 1/2, 2's cancel. You get 1/5. Okay. There's another step we need to do. What?
I said wouldn't you subtract, but I was talking about the other problem.
Okay. And I wanted to point that out. So, are these bases the same?
Yeah.
So, can I combine them? No. Okay. So, the bases aren't the same, so I can't combine them. But let's take a peek at these in radical form. What's 3 to the 1/2 equivalent to?
3 squared. Square root of 3.
Yeah, what he really meant to say was square root of 3. What's 32 to the 1/5 mean?
5th root of 32.
The 5th root of 32. Do we know either of those? Do we know the square root of 3?
Sure. Is it not?
Square root of 3 is some decimal, like 1.7 something, I don't know. 5th root of 32. We did several times yesterday. The 5th root of 32 we learned to be 2, which means I can simplify this to be square root of 3 over 2. That's how I would probably leave my answer in this case. Now, I'll be honest, I do have an or here. And I have or as in you could leave it as 3 to the 1/2 over 2. I personally probably like the first one better, but that's equivalent, okay? Unless you have a very specific direction that says radical form, either would work, okay? Okay, guys, it's all about exponents. It's algebra 2. I'll be honest, these aren't the easiest exponents to work with, especially when they throw in fractions and all of that. But this is what you need to work with, okay? So you do have a homework. You have a little bit of work time. Crazy thought there. Okay. There's a couple of you that don't have 5-1 done if you wanted to work on getting that finished up. Otherwise, start working on 5-2 part 1. And it is listed as due tomorrow. We'll start into 5-2 part 2, but it's going to take us Thursday and Friday to do that one. Okay?